This video, make sure you have a decimals calculator handy, a piece of paper, something to write with, because it's going to lead into what I'm going to grade you, called the magnesium activity. So I'm going to call this the magnesium activity notes. Alright, so you're going to get, the challenge will be you need to calculate the percent of the known isotopes of an element, calculate the average atomic mass, and create a mass spec graph for the assignment. But this is the tutorial, so here we go. We have a sample of an element and we put it into a mass spec machine, which is how we get those graphs. And so we have the information. So the machine gave us this. Basically counts and separates the isotopes, light isotopes, heavy isotopes, and then it counts them for us. And so here's some of the information and what it will look like. The machine separated this element into the known isotopes, and one of the isotopes has a mass of 2, and the machine counted 7 of them. There's an isotope that has a mass of 4, and there's 4 of them. And last is the heaviest, an isotope of 6, and there's 1 of them. Well, the first thing I need you to do is find a percent. A percent is pretty simple to find. Well, you need to know the part. The part is the number of atoms. And you also need the whole. Well, the whole is all the atoms totaled together. So 7 plus 4 is 11, and 11 plus 1 is 12. So now I have all the information to find the percent. When you're asked to find percent, you will not use mass. You use that for the average atomic mass, but you will not use it right now. So that's why it is X'd out. Alright, to calculate percent, part over whole equals X over 100, we set up a simple proportion. So if we put the data in for isotope number 2, isotope number 2 is the most abundant because there's 7 out of 12. And so when I have a proportion, the first thing I do is cross multiply, and then second I divide. So I'm going to switch to my calculator and multiply 7 times 100, then divided by 12. So in my calculator, 7 times 100 divided by 12. If I enter it in that way, I only have to do one thing, and so that is cross multiplying 7 times 100 divided by 12. I get the percent of 55.83 repeating. Sorry, my data went away here. Alright, so that was 7 out of 12 equals X over 100, and that gave me a percent of 58.3%. Okay, now the next one we had isotope 4, and there was 4 of them, so I would set it up. 4 atoms out of 12 equals X over 100. So I go to my calculator, so use my parentheses. So 4 times, because I'm cross multiplying, 4 times 100 divided by my total of 12. My percent for isotope number 4 is 33.3%. The last isotope had a mass of 6, but there was only 1 of them. I can do this one of 2 different ways. I can set up a proportion in which I say 1 out of 12 equals X out of 100, cross multiply and divide, or I can do this. I can add up the two totals. I know that isotope 2 has a percent of 58.33 or 0.3%, and isotope 4 has a percent of 33.3%, and that gives me a total of 91.6. I subtract from 100. Isotope 6 has a percent of 8.4%. So now that I have my percents, so that's the mass, this is the atoms, and I need to add this and that, so I have a total of 12. All right, now I need to calculate the atomic mass of my data. Well, this time I do not need this information of atoms. I need my percents in the form of a decimal, and I need mass. So I'm going to plug it into my average atomic mass formula, and we're going to calculate the average atomic mass. So the mass, and I'm going to go lightest to heaviest. Isotope 2, so this is where I need mass. Mass times percent in the form of a decimal, 58.33 or 58.3. Move the decimal over 2 places to the left, it becomes 0.583. I need to multiply isotope number 4, or mass isotope 4, times the percent in the form of a decimal, so 33.3 changes to 0.33. And the last and heaviest isotope, isotope 6, multiplied by its percent, move the decimal 2 places to the left, is going to be 0.084. That's what it would look like. Because I'm doing average atomic mass, it is mass times percent in the form of a decimal. So let's go to the calculator. Let's put in our masses. So isotope 2 with a percent of 0.583 times, or added to the mass of isotope 4 times the percent of 0.333. Isotope 6 times the percent 0.084, and that's to be expected, 3.002. My answer has to be mathematically, it has to be between 2 and 6, but because of 2 having the most abundant isotopes, I'm going to get an answer that is closer to 2, but because of isotope 4 and isotope 6 being heavier and 4 is quite a bit abundant, my average mass for this data here seems to make sense of 3.00, I can't remember what it is, 3.002. And the last thing you'll need to do is construct a mass spec graph. Things you need to know, a mass spec graph. We have our y-axis and we have an x-axis. The x-axis is where we have mass, and so you're going to put the mass, because of our data from this tutorial, we have a mass of an isotope that has 2, we have an isotope that has a mass of 4, and we have an isotope that has a mass of 6. Over here we can put number of atoms, because a mass spec graph actually gives us a percent. And so how many atoms did we have of? I'm just giving a scale here. How many atoms of 2 did we have? Well, we had 7. How many do we have of 4? Well, we had 4. And what happens is, if you do that based upon your parts, these bars actually are very accurate to the percent. That bar on isotope 2 is and will calculate to be 58.3%. And then isotope 6 only has one atom, and it should get a very tiny bar. And this is what our mass spec graph looks like. We go from lightest isotope to heaviest isotope, and then we put in the number of atoms, and we have created a mass spec graph for that element. So please use this information to complete the mass or the magnesium activity. That will be a grade.